Hi everybody, welcome back to lesson 4.1. Today we're going to talk about the last page and a half or so about this lesson, part 2 as we're going to call it, and it starts on page 43 in our Springboard books, and today you are going to need a pencil, possibly a highlighter, and definitely a calculator to check your work, okay? Now reminder, we talked about in part 1 of 4.1 the idea of a midpoint. And a midpoint, reminder from our last lesson, cuts a segment into two congruent smaller segments. So for instance, M is the midpoint of PQ is what we talked about in the last lesson. So we're going to keep working with the idea of a midpoint today in order to solve using a little bit of segment addition postulate as well. Now notice in the example given that this is a really good example for you to look through if you are stuck to kind of follow along with an example. And notice one thing that's really important each time is that you draw a picture to keep yourself organized. So always make a sketch of your segment before we get started so it's easier to label. Okay, so we're going to start with the try these part A. I'm going to draw it up here. And notice they're telling us that Y is the midpoint of segment WZ. So that's where we're going to start. We're going to draw segment WZ, and we are going to make midpoint Y in there. And we're going to mark our segment, the two pieces congruent, so we don't forget later that we were given this as a midpoint, so we know that the two smaller segments are congruent. Now we are also given in this information that segment YZ is x plus 3 and segment WZ is 3x minus 4. Okay, notes WZ. Now, we chatted in the last lesson about taking small guy plus small guy and having it equal the big guy, right? Small segment plus small segment equals the bigger segment. The problem here is we are given that YZ is x plus 3, and we're given WZ is 3x minus 4, but we don't have given to us what WY is, okay? What do you think it could be? It is going to be x plus 3 as well, because we know it is congruent to our other segment because y is given as the midpoint, okay? So we're allowed to say x plus 3 plus x plus 3 equals 3x minus 4. Small guy plus small guy equals big guy, okay? Now as we start solving, we want to make sure we combine our like terms on the left, and on the right hand side, we have 3x minus 4. And now that we have everything condensed down, we can start moving things around. So we can subtract 2 x's from both sides. We can add the 4 to both sides. So we end up with 10 equals x. Now a reminder that the problem wasn't asking us for x, only it wants the length of WZ. So we need to make sure we plug back in for WZ back into 3x minus 4. So 3 times x minus 4 is 26. That's our final answer there. Okay. Now we are also going to want to do the same process here for our next two examples. Okay. So for part B, notice in this example, when we draw our picture, we are given segment RS and M is the midpoint. So I'm going to draw my segment RS, M is the midpoint, and because they told me it's the midpoint, again, I can mark these two congruent. Now notice this time we are given that Rm equals x plus 3, get rid of this, x plus 3, and we're given ms, the other small segment, is 2x minus 1. Now notice this time we have small guy and small guy. What we don't have is big guy, so we're not actually going to use segment addition postulate. When we're given the two smaller segments and we know they're equal to each other in length, in order to solve for x, we can set them equal to each other in order to solve, okay? So in this case, we end up getting x to be 4. And when we plug it back in for Rm, 4 plus 3 gives us 7 as the length of Rm. Take a moment on your own in a space you can find, maybe down here over to the right potentially, to solve letter C on your own. Remember to draw the picture using the given information, label it, and then solve. Now, number 14 introduces to us another important vocab word, and that word is bisect. Okay, when we have a midpoint, we bisect our line segment. And what a bisection is, whether that's in a line segment or eventually we'll talk about it in angles, is that we are cutting it into 2 equal pieces, okay, or congruent parts. So in number 14, if we have line segment WZ bisects XY, okay, it means WZ is going to cut segment XY in half. WZ is doing the cutting, right? It is bisecting. So we're going to say that here's XY, segment WZ is cutting it in half, is bisecting XY at point Z. Okay, so really we could even cut this picture up a little bit here. What we're showing is this guy, WZ, cutting XY. Okay, so a reminder, anytime you see the word bisect, you're going to also want to think congruent. Okay, now, talk about vocabulary in class. Last 2 things I would like to talk about on here. The first one is going to be number 16. And what number 16 is saying is, Mackay knows that GH is equal to 7 and HJ is equal to 7. So based on this information, he claims that point H is the midpoint of GJ. Is his claim necessarily true? Make a sketch that supports the answer. Now, if they had said collinear as a keyword in here, then yes, that would be true. We would say, okay, well, we have G, H, J, and both of these are 7, so they're congruent, okay? But what they didn't do was say that word. So we can't assume that unless they told us that H was between. Because what could happen is this could be GH and this could be HJ, and they could both be 7, but they're not, this is not a midpoint, right? Because it's not collinear. So the key word is here, if collinear were involved, we would have been able to say yes, but otherwise we're going to have to say no. And this is the counterexample on that. So collinear was important, that we're between. Last but not least then, let's talk about number 18, which says that AB lies on the number line and that point A is at -6. And if we know segment AB is at 20, what are the other 2 possible coordinates for point B? Well, point B could be here. We also talked about point B could be here, because you could be AB to the right, or you could be AB going to the left, right? So if the whole segment is 20, we know we could be going 20 this way, or we could be subtracting 20 that way, right? So the 2 possible locations, if we subtract 20 from -6, point B could be at -26, but B could also be at -6 plus 20 if it moved to the right, aka it would be at +14. Okay, so your 2 locations for B, if it's moving to the left, it's at -26, right, it's at +14. Okay, all right, thanks everyone.